Hey y'all, today we're going to go over our EOC number 1, 23 through 39. So that number 23 right there is saying that if you have an inequality and it wants to know what's the largest value, smallest value, the difference. So if we actually go and look at our Desmo screen here, whoops, sorry about that. If I go and look at my Desmo screen, here it is. So I've got more than one thing on here, but all I did was type that in. Notice with an inequality, just like if it's an equal for a circle, it all goes on one line, or an inequality all goes on one line. But everything else, if there's an equal sign, you're going to block it up with left side, right side. But circles with an equal sign go on one, and then your inequalities go all on one line. So when I look at this, it's asking me what is the value, what is the largest value? So the furthest that this thing goes over is right here, which if you can tell that that's a 3, so that would be the answer for the largest. And now it wants to know how far I go over this way. So I'm going to just keep coming here, and I can see that the furthest that it goes over that way would be a negative 17. So back to my paper, again, 3 was my largest value, 17, negative 17 was my smallest value. What's the distance or the difference between them? You're always going to take your numbers and you're going to subtract your numbers and find the absolute value. So 3 minus negative 17 would be positive 20, and then the absolute value of that would be 20. If you had said negative 17 minus 3, that would have been a negative 20, but the absolute value would have made it be 20, because remember, distance has to be positive. For number 24, this is those questions where we're talking about the tolerance levels. So we've got, this time we're talking about, you want 54 ounces of macaroni and cheese. We're going to discard it if it's off by more than 0.37. So this is the one where we always look for x minus what's it supposed to weigh, less than or equal to tolerance. This does not say less than, so I'm going to throw it out. This is not the tolerance, so I'm going to throw it out. One of these might be right. Coming over here, it's always got to be the x minus. You know, how much is that box off by? Well, it's supposed to be whatever the x is, whatever the box weighs, minus what it's supposed to is going to tell me how much it's over. So C is my answer to that question. Then the same kind of questions are being asked about the same, this is the same question is what I'm trying to say. So the largest that weight that box can be would be your, the ideal weight, which was 54, or your target weight, plus that tolerance level or minus that tolerance level. All right, then we get into some questions. These next ones are going to be dealing with transformations. Those are all just notes to remind you. But down here for number 25 says write the new function if, that should say, we're going to write that new function if f of x equals 8 to the x. If that is transformed to the left, so with your x, up with the x, left is going to be plus 9. We're going to have this x plus 9. A vertical compression, vertical is going to be on the outside, so that's going to put this 1/3 here. Remember, it was 8 to the x power, so that's just your original 8 to the x right there. But we had to group my x plus 9 to make it move to the left, and in front, that's going to do a vertical compression. Reflected over the y-axis, well, that's the y is going to be up here again with the x, but it has to be outside of this x plus or minus a number. And then the plus 3 moves it up 3. That's got to be way here over at the end. All right. If you brought that negative in, it would look like negative x minus 9 plus 3. Either of those are acceptable answers. So we can either take this as an answer or this one as an answer. Okay, they give you negative 3 times 4x plus 12 squared minus 5. List the order of transformations. So what's happening here, remember this is where we used to put all those little arrows up. That negative is going to reflect it over the x-axis, right? So that negative is going to reflect me over the x-axis. It's a 3. 3 is bigger than 1, so it's on the outside, so it's vertical. It's vertical, it's a stretch because it's bigger than 1, because remember the negative just flipped it over. So with a scale factor of 3, it's a vertical stretch. Working on the inside here, oh, by the way, the first thing we had to do, sorry, I wasn't paying attention, you have to actually factor that 4 out so that it's just x plus or minus a number. So when I factored that out, this is the equation I'm working with here. All right, so the 4 is inside with the x, so it's a horizontal. It's the opposite of what I see, not the opposite, the reciprocal of what I see. So I see a 4, my scale factor is 1/4, that makes it a compression. Wacky world of x, I see a plus, so that's actually going to move me left 3, and then outside with a minus moves me down 5. For 27, if you're given that function, they want you to find the domain. Go ahead and put that in Desmos, and it's going to give you a graph that looks something like this. All right, so the domain, you can see arrowheads with no blocks stopping me from going from left to right. That's my domain. So it's not going to affect anything. I'm going to go from negative infinity to positive infinity, all real numbers. But my range, even though I have arrowheads here, I get stopped right there. And if you're looking on your graph at your Desmos, you would see that this would be a -2. So I can't go any higher than that -2. I can't get there, so it's a parenthesis, and infinities always use parentheses. You could also write it as y has to be less than -2. So that's your domain, that's the range. You actually have a horizontal asymptote that's running across there at y equals -2. It didn't ask you this, but the end behavior for this would be, as you are on the left side of your graph, you're going to get closer and closer to -2, and as you're on the right side of your graph, you're going to get closer and closer to negative infinity. Oh, so sorry. It did ask you those questions, but they're on the next page, so we've already talked about, we've already answered those. So let me scooch this to get where we need. So we've just talked about these two answers up here at the top. Oh, I don't know what I just hit, so let me stop that. All right, number 28. This is if they give you a graph, if they give you a table and you want to go to Desmos to make that table, the first thing you're going to do on Desmos is you're going to hit the little plus sign and you're going to make a table. You're then going to enter this data into that table. And then if you want an equation, because they want an exponential equation, we need to write our general exponential formula, which is ab to the x. But you'll notice that I have an x sub 1 and a y sub 1 here, because you're going to notice when I switch now and go to my Desmos screen, that it's actually going to show you, all right, so I actually went to that plus, right, and hit the table, and it gave me a table. I filled in the values that were there. Then I'm going to go to my next box down here, and I'm going to type it in as y sub 1. You have to use a tilde, not an equal. And then ab to the, and it has to be x sub 1. And you literally just type y1, x1, right? And what it's telling you here is it's going to use this x1 and that y1 for these values, and it's going to find the graph that comes closest to what we want. So when you look, the most important part here is looking at these parameters, because that's the a and that's the b. So my a is 2.9, you can say 2.92, you can write it all out if you want to, and then my b is 1.2. So again, I went up here to the plus sign, I clicked on table, it popped up a table that was empty, I filled in the values, then I have to go to this next box and type in the equation, but I don't use an equal sign, I use the tilde, and that's right next to your, it's usually right next to on the left side of the number 1. You'll have to shift to get to it. So coming back to my question here, notice how I had my a, that was the a that came up in the parameters, that was my b. Those are the numbers that I'm going to put in for the a and the b, and this is the answer. Desmos will do it for you. All right, number 29 actually 29 through 31, we can use Desmos. This is saying you've got 4 to the x plus w. Find the w if the y-intercept is 0, 6. So you can either go ahead and plug that 0 in for the x and plug the 6 in for the answer, the y, and solve it, right? So that's 1, which would scooch that over and become, if I subtracted 1 from both sides, my answer is w equals 5. If you want to go back and use Desmos, you can, and I'll show you that in just a second. This one, new equation, find the w if the y-intercept is 0, -2. Again, put that point, that x and y point right there, put that x and y point right there into this equation and solve it. So I've got, there's my y, equals w times 5 to the 0 power. Again, anything to the 0 power is 1. That means my w is a -2. I personally think it's quicker to just do the math there by plugging in the numbers. But if you go back to our Desmos, right, and I come over here, and I've actually typed in that first one. If I add a slider, and then what I'm going to try to do is I want to see when will that have a y-intercept. Find the w if the y-intercept is 0, 6. Okay, I need this to be up here at 6. So if I move that until I get right about there, it looks like I'm crossing at 0, 6, and I can get my number right there from my that scalar. What did they call that thing? If I get rid of that, okay, slider, that's what it was called, not a scalar. So the next question was w times 5 to the x power. So yes, I'm going to go ahead and add a slider to that. I could have used the same slider, but when you're using Desmos on your EOC, it's going to give you a new Desmos every time, so you would have had to type it in and add the slider. This time we want our y-intercept to be at 0, -2, so I want to be down here. So I'm going to start moving this thing. I'm going in the wrong direction, so let me come on back down here. I need to keep moving it until I get right about there. I'm just going to double check that that is, yes, that is the point 0, -2. So then I come over here and I see that my w is a -2. And that's the same stuff that we got. That just shows you how you can use a slider if you want to. Okay, number 31 says solve. So all of these are different problems, but we can put each one of them in Desmos, right? I can put this in my box 1. I can put this in my box 2. Remember, if you get a question like that, and for whatever reasons it doesn't work in Desmos, because you have these up front, then you want to bring that down and write x plus 1 times log base 10 of 5, and then that's going to equal 2x plus 5 again in parentheses. That's my exponent. And then log base 10, oh, it's a 3. Log base 10 of 3. You may have to change. Sometimes when you get questions like this, if you get questions like this, Desmos won't take it. But if you bring that exponent down in front and say the log base 10 of the number, of that base 10, of that 5 right there, and then say, bring that down in front and say log base 10 of 3, then box 1, box 2, it will give you your answers. And the rest of these, again, you can type exactly like you see it. All of this in box 1, y equals 12. You will have to put a y equals for that one. You'll have to have a y equals 24 and a y equals 3. But all of those should work in Desmos, and you're just seeing where they cross, where they intersect each other, and you want the x answer. Okay, number 32 is asking you to find the inverse of these. We've done a few of these already, but let's try them again. So number 32 says find the inverse of f of x equals 5 raised to the 3x minus 2. And then I'm going to do f of x equals 4.3 to the x minus 6. Okay, now that I have them written, I'm going to actually work through these two inverse problems. Okay, so not that first part, just right here. My f of x becomes a y. I change my x and my y, and then I solve for y. Well, this y is trapped up here as an exponent. It is in the form of base to the exponent equals the stuff, so I'm going to change its form, and I'm going to write log base, save a little space, equals the exponent, and the part that I hadn't written goes in my space. And now we're in the home stretch. Get that y by itself, I'm going to add 2, divide by 3. So that's going to be log base 5 of x. I'm going to add 2 to it. That's going to be equal to 3y. Then I'm going to divide through by 3, and that's going to be my answer, right? Because that's going to cancel, leaves my y by itself, which would be the inverse. So this is the answer to that first question. This next one, this is a y, equals 4.3 to the x minus 6. Switch out my x and y's. Now before I can do anything, my y is what I want to solve. It isn't an exponent, but this is not by itself. So I have to add that 6 first. So x plus 6 equals 4.3 to the y. Now I can change its form. So log base, save a little space, gets filled in with that, equals the exponent, and I filled in the space with what I hadn't written yet. That is in equal to y, so that is the inverse. And so those would be the two answers that we end up with. All right, and that again is showing you log base 5 of x plus 2 divided by 3, and then the log base 4.3 of x plus 6. And those are the inverse answers that we just got. If for some reason, again, it looks a little different on your multiple choice answers, go ahead and put your answer in box 1, put the multiple choice answers in box 2, and see, you know, the A, B, C, D in box 2 one at a time and see which one lines up. All right, number 33. Ooh, these were those formulas that we had to talk about with our interest. Given an initial deposit, so there's your P, there's your principal, in accounts A and B, what will the difference, so that's my question, what will the difference be between these two accounts? 5 years, there's your time. If account A has 4.5%, so that means I got to change that to 0.045. Compounded continuously, as soon as I see compounded continuously, I think PERT, that's principal, times my Euler number raised to the rate times time as an exponent. Account B has that same 0.045 as my rate. Compounded quarterly, quarterly makes that n be a 4. So here are the formulas I'm going to use. Look, those are my principals. E raised to the 0.045, and then I'm going to multiply that by the time, that is a 5 right there. So that's going to give me an answer which is $10,018.58. This formula, right here, that's 1 plus r. That rate is still has to be the same rate. See, your P's are the same, your rates are the same, your time is the same. The only difference is this used continuously as an E, and this is quarterly, so I have a 4 in both of those places. And that gives me $10,006. So the difference you actually have to take then is what's the difference between these two things right here, and you do get $12.58. I'm going to, again, highly recommend, since we didn't always do so great on our test for this section, go back and put this in Desmos and make sure you're getting that answer. Put this in Desmos and make sure you're getting that 10,006. Because if you're not, please ask to get help to figure out what you're doing incorrectly so that you can get the right answer on your EOC. All right. This one says, I'm not quite sure. Oh, we would just be doing it quarterly. it's not really just doing quarterly, but compound quarterly is this one right here, and that's your compound continuously, right? Compound quarterly, because it has that compound quarterly again, that's this part right here. I'm not quite sure why I wrote that little note to myself there. So number 34, if you're given A times 1.2 to the T, what is the approximate monthly interest rate? So monthly, remember that means you have to raise this B right here to the 1/12th power, because there is only, you want 1 out of the total 12 months of a year. And then when we're talking about that, what is the monthly interest rate? What is the growth or decay? You need to decide whether you're going to actually multiply that or subtract that thing, B minus 1 or 1 minus B, but I want it to be a positive number. 1.2 is bigger, so I can take 1 away from it and still be positive. So it's this number, B, right, that is my B, and that formula is B to the 1/12th power minus 1. That's going to be my monthly rate. How many years before this account is going to double? Well, it started at 200, so 200 times 2 is where I'm getting that 400. That's when it's doubling. So when does this equal 400? Y equals 400 in Desmos box 1, 200, all of that to the T in Desmos box 2. You can put it to the X if you want and see where they intersect, and it's going to be about 17.7 years. Number 36, a bacteria triples every 5 hours. That triples means you're not going to have a rate. You immediately write triples, put a 3. Triples, put a 3. Every 5 hours /5. Starts with 20,000, that's your start at. Find the number of bacteria after 40 hours. I was 5 hours, so 40 is my time. 40 goes on the top, and that actually, you can stick that whole thing exactly like you see it in Desmos, and it'll give you your answer. But every time you have a double, triple, or half-life, whatever the double, triple, or half-life goes as your multiplier, it'll tell you every something that goes on the, remember it's a fraction up here, that goes on the bottom, the time goes in the top, the every goes on the bottom. And your start at, your principal starts in the front. Right? Number 37 here is talking about same kind of thing here. We're estimating the frog population in a county is doubling, so double, that puts a 2. Every 20, that's the 20 goes on the bottom. My time goes in the top, and I need a start at. In 1990, the frog population was 9 million. How much will it be in 2020? That's the time. From 2020 to 1990 is 30, so 30 years is going to go on the top. It said you had 4 million. You can just put the 4 there, but remember your answer has to say millions. Again, I'm going to put that in Desmos, and it'll give me my answer. Number 38 is a half-life problem. So half-life, I put a 0.5 or a 1/2 in there. It has a half-life of 15 hours, so that's every 15 hours it cuts itself in half. So how much of a 9 gram, that's your start at, would be after 50 hours? That's your time. So half-life, every goes in the bottom, time goes on the top, start at goes in front. There's your answer. All right, and then the last one that we have to do on this page is number 39. Find the K given the graph. Again, if this is a point that's on that graph, I can use that 0.05, and I can come in here and I can say, okay, then the 5 is going to be my Y, my 0 is going to be the X, so I'm going to do that work here, and that's going to be K equals 5. Again, I think that's the fastest way, but you could also go through, put this in Desmos like we did before, put a slider, click the slider on for K, and see where are you going to be crossing up here. Where would that graph be crossing at 0, 5? All right, and that finishes up that section.